Hello all. So today we will talk about exercise 3.50, cart, ball, and plane. So this question is about a cart that is going down an inclined plane, which has a tube inside it, and the tube points perpendicular to the plane, and it shoots out this ball, let's say with velocity u. And it is asking us, will the ball eventually land back in the tube? So this question also told us to choose our coordinate system wisely. So the first way to deal with this problem is to do it in xy axis, the xy plane, which is quite difficult since this ball will have a trajectory of a parabola, and then this cart will have a trajectory of just a line going straight down. And this question just becomes finding the intersection of a parabola and a line, and it is quite complicated. So let's try another coordinate system that is much easier. What if we tilt this setup? What if we sort of tilt this whole setup? So to make it more clear, what if we tilt it like this? Would it be easier? So why don't we try? Let's first analyze the force in this coordinate system so it's easier to understand. So what does the car experience? It experiences a gravity, a normal force, and then for the ball, it also experiences a gravity. So then now let's try to turn this whole setup a bit. So if I just select this, and then we can just tilt it a bit. Now obviously you can't do this when you're using a paper, but this is just helping us to visualize it. And obviously we can just do it without this as well, just try to imagine it. But this is one of the ways to visualize it better. So now gravity points sideways, and then we have the normal force pointing upright, so perpendicular. And then so the ball will have a velocity straight up. So the velocity of the ball will be straight up. And then this cart, the setup will have an original velocity too, called v0. And then let's call this u0. And so let's try to figure out. So what do we know? Well, we know that prior to launch, let's erase this first, so less distractions. So prior to launch, the ball is with the cart. So we know that x ball equals to x cart. So just as a reminder, now this is our new x axis, and this is our y axis. So just keep in mind that this x and y isn't really the x and y in this frame. So it will look like this. But then we're just using this and that as the xy axes. So x ball equals to x cart all the time prior to launch, because the ball is in the tube and the tube is on the cart. And so that is true. And then what else do we know? We know that their velocity is the same too prior to launch. Because again, the cart is carrying the ball, and the ball is not moving within the cart. And then how can we approach this? So when this ball launches, it experiences gravity, which now points sideways. And gravity has two components here. So gravity, so just to help visualize, if we say this is theta, then this should be theta. Why? Well, if we just draw it in this frame, let's just draw a block. So if this is g, then this is theta, right? And then so this would be 90 minus theta. So when we invert the system, not invert, when we rotate the system, we get sort of a shape, and then that is still your 90 minus theta here, and theta. So if this is theta, this is 90 degrees, and so this is 90 minus theta. And so then if I just draw another line just to make it easier, and now that is 90 degrees, this becomes theta. And so now we know that the acceleration in the x direction is g sine theta. And in the y direction is g cosine theta. Now, keep in mind that both the cart and the ball experiences the same acceleration g. Although their force is different, so although this force and this force, they are different. So let's call this g1 and g2. Although g1 and g2 are not the same, the acceleration they bring is the same. Why? Well, because acceleration is just force over mass, right? And since they differ by a mass, when we divide them by mass again, they all bring the same acceleration. And so this expression is for both the cart and the ball. So now we know that they experience the same acceleration in the x direction and in the y direction, and not in the y direction, but same acceleration in the x direction. And that is enough to know that the ball will always fall into the cart. Why is that so? Because the ball at one point, when this cart is traveling, let's say it's here, at one point this ball is going to come back down to the height of this plane here at one point. And if their x direction is always the same, then the ball doesn't have a choice. It will always have to land in this cart no matter what. So it might be here, and then next this they'll be here, and next it'll be here. But no matter what, their x coordinate is always the same. And then at one point when this ball has to fall off sometimes, since there is a net negative acceleration in the y direction, it will come down one time eventually. And when it eventually come down, it will land right in this cart. And so that is why the ball will always land back in the tube. And if we've chosen a coordinate system just using the normal xy axis, it will be a lot more complicated. But with this new system that we chose, it's actually easier and we don't need to do much calculation. Thank you for watching.